This video is going to recap some things that we've already learned about the functional group, the alkyl halides, and then get you ready to start looking at the reactions of this functional group. So we know that the notation for an alkyl halide is Rx, where R is a carbon-containing group, and specifically in this chapter we are going to be looking at a sp3 carbon bond to the halogen. We also know that there is a dipole moment because of the difference in electronegativity between carbon and the halogens. So there is a slightly negative charge toward the halogen end of the dipole and a slightly positive charge toward the carbon end of the dipole. So because of this dipole, you of course can have dipole-dipole interactions between two molecules of an alkyl halide in addition to the dispersion forces that are being exhibited. And just like with the alkanes, the more carbons you have, the higher the boiling point would be for an alkyl halide as the dispersion forces increase with the length of the carbon chain. So just like we learned before with the alkanes, the more elongated the structure, the more dispersion forces that can be exhibited along the surface of the molecule. So even though both of these structures here are both composed of 3 carbons, having the more elongated cylindrical shape is going to lead to a higher boiling point because of an increase in dispersion. We classify alkyl halides based on the type of carbon that the halogen is connected to. So the most simple kind of alkyl halide you could have would be the methyl halide, where the carbon is surrounded by all hydrogens. If you put a carbon with 2 hydrogens and 1 R group, that is called a primary halide. If X is connected to a carbon that has only 1 hydrogen and 2 R groups, that's a secondary halide. And then finally we have a halogen that's on a carbon that's surrounded by 3 other carbons, and that would be the tertiary halide. In terms of reactivity, because of this dipole moment and because of the lone pairs on the halogen, we have a nucleophilic end of the alkyl halide and an electrophilic end of the alkyl halide. In this chapter, we're going to study reactions that take place at the electrophilic end of the alkyl halide.